And that's the stock exhaust.
All right.
You see the problem with these right here? It leaks. All of them.
That's good. We're not even at VY.
6 o'clock.
Isn't that cool? That's cool.
0,
22 Celsius. Getting down to VY doing 1,000 feet a minute with 3 people on board.
901, crosswind turn is approved, so call the base.
Crosswind turn approved, 991, we'll wait for your call.
So we've done exhaustive research. I know it's a lot to intake, but, you know, feeling under pressure.
I'm Josh, a pilot and flight instructor who loves the sky, sharing it with those around me and using it to see the world from a new perspective. Flying can seem super complex, but I make it my mission to promote safe practices while enjoying the beauty this world has to offer. Subscribe to Climb Into the Cockpit on future adventures. This is Aviation 101.
0991 New Orleans, clear to the Foley Airport via S5 on departure, maintain 2,000 feet, expect 7.
Chelsea and I have flown November 80991 all the way from San Marcos, Texas to Daytona Beach, Florida, home of PowerFlow Systems. The last 2 videos on YouTube cover the 2 days of IFR cross-country flying it took to get here, and they include some really good insight to my decision-making process and how I work through my planning when it comes to long trips. Definitely check out those previous videos right here on Aviation 101, and the full-length edits of those flights are also on Cockpit Club. I've been looking at getting a PowerFlow tuned exhaust system for our Cessna 172 for 8 years now, ever since we bought it. And I started chatting with PowerFlow Systems back in 2019 about how we could really encompass the benefits of their tuned exhaust system for YouTube, and we finally made it happen at the very beginning of 2021. This video is actually going to cover 4 days worth of footage, a before test flight with the original stock exhaust, the installation of the PowerFlow, an after test flight on the new exhaust, and a short debrief of the data we gathered on both flights. In that time, we also installed a Challenger air filter kit. It's basically a high-performance air filter that's STC. And we also did a dynamic prop balance, which doubled the warranty on the PowerFlow exhaust to 24 months or 500 flight hours. And that actually showed that my prop was way out of balance to begin with. Effectively, the Challenger air filter is going to help the engine breathe in better, and the PowerFlow exhaust is going to help the engine breathe out better. We start this video at the PowerFlow factory in Daytona Beach, where we got some insight from Jim Schaefer about how the tuned exhaust does this.
When the engine is rated, they do it on a test stand with 4-inch neutral stacks, which impose absolutely no load on the engine. As soon as you take those neutral stacks off and put on any exhaust system, it's going to restrict the horsepower to a certain extent. And what the standard designs on most general aviation aircraft actually reduce the rated horsepower by anywhere from 25 to 35 horsepower. And what the PowerFlow will do will give you most of that loss back, up to about 95% of the loss. So instead of losing 25 to 35 horsepower on a 160 horsepower engine, you're going to be making about 157 to 158 horsepower with a PowerFlow equipped engine. You're not increasing the rated horsepower beyond the rating level. You can't do that. But you are getting much more of the engine's rated horsepower developed and delivered to the propeller.
Okay, so basically the gist is that the stock exhaust on these old engines are not tuned for performance and efficiency, and because that wasn't a priority in design, they in fact restrict the airflow of the exhaust out of the cylinders, and thus restrict the airflow of combustible air fuel charge into the cylinders. Basically, the engine isn't breathing as freely and efficiently as it's capable of with this old set of pipes and a big can muffler. Chelsea, Darren Tillman from PowerFlow, and myself are going to take November 80991 out over the Atlantic Ocean, hence the inflatable life vests, and we're going to run a thorough performance profile to gather data on how my engine runs with the stock exhaust. We'll be paying close attention to the engine's revolutions per minute, RPM, fuel flow, which is measured in gallons per hour, cylinder head temperatures, CHTs, and a reading of the exhaust gas temperature from each cylinder, EGTs. I learned a ton of stuff on this flight, one item being the relationship between the CHTs and the EGTs is really important for determining the efficiency of the exhaust system. More on that later.
All right, so we're going to do a normal PowerFlow test profile, which is where we want to establish the performance differences between the standard exhaust system as you got now and once you install the PowerFlow. And we're going to do it in ideally the same conditions, exact same weights, same pilot techniques, same kinds of airspeeds. So the first thing we do, we're going to do a climb from sea level. So what we're going to do is, because we're near the ocean, We go a couple miles offshore. That way we have the no real lifting effect from the ground because we're over the ocean. We also avoid a lot of traffic. And the idea will be we'll get down around 700-800 feet, position so we can do a straight ahead climb without any turns unless we have to for traffic. And we're going to climb straight ahead from 1,000 feet up to 8,500 feet.
Okay.
And what we're going to do is once we pass through 1,000 feet, you're going to slow the airplane down to VY. You'll establish VY, go to full power, keep the VY pitch. So between 700 feet and 1,000 feet, that's your time to fine tune your pitch. We don't start the time until we hit 1,000. When we hit 1,000, we're going to start a timer.
Okay.
Every 500 feet, you're going to give me a call out. Hey, approaching 1,500, approaching 2,000. Once we hit that, ideally, one of us will figure out who can read the timer better. We'll say the time, and you're going to tell me the airspeed in average you've been holding.
Okay.
I'm going to record airspeed, outside air temperature, RPM, and I'm going to attempt to record as many CHT and EGTs and fuel flows as possible. Thankfully, the camera is going to back it up.
Right.
So what we'll have when we're done is we'll have time hacks every 500 feet.
Okay.
We're not going to record rate of climb, we're going to calculate it.
Okay.
Just easier.
Yeah.
Because it's instantaneous instead of actual averaged.
Absolutely.
Once we get to 8,500 feet, we'll transition to a cruise speed profile. So what's the favorite RPM you like to cruise at?
I like 2450. usually.
2450. That's a great number for the 172. Also, the perfect RPM for the PowerFlow.
Okay.
Because the not super secret issue is the tuned exhaust system has a totally peak RPM response. It's at 2450.
Perfect.
So you've accidentally been perfect for the test right there. So what we'll do is we'll go up to 8,500 feet and we'll start at a lower power setting for lower cruise speed, say 2,300 RPM. We'll set the engine to 2,300 RPM and we'll lean it. We'll lean using your normal technique and then we'll lean it a couple of other techniques. One of the other things you'll see with the PowerFlow is that you can actually lean the engine, lean of peak, safely, effectively, and with the same output, dramatically cooler temps. So we'll get our baseline data for that. On this. We'll choose 2450 and we'll also do a wide open throttle number. Because in the end, more power should mean more RPM. And up at 8,500, we can do so safely. We'll then come down to 5,500 feet. We'll repeat those numbers.
All right, are you ready?
I am ready, sir.
All right, I'm ready.
So just to recap, as you pass through the 1,000, let me know it's hitting. Start time, yell out the airspeed, and I'll record as much else I can.
Okay, good deal.
All right.
We're going to try and maintain 80 here and either to full power. And we're going to maintain this track of about 350.
Well done.
All right, we're established on 80, full power. Crossing 1,000 now, 82 knots.
Got it. All right, outside air temperature, I'm going to go with Celsius 17, 2460 RPM. Fuel flow appears to be 14.6. Good number.
Crossing 1,500 now, 52 seconds, 81 knots.
Now because it's carbureted, the fuel flow will boggle a little, jump around a little bit. So we kind of look at it and try to just take a weighted average.
Gotcha. Crossing 3,000, 3 minutes, 49 seconds, 81 knots.
Copy that. Outside air temperature is 12 degrees. Back to 2440 now. Your EGTs are awesome.
Good. Yeah, they're definitely much lower now after the carburetor got done. All right, there's 3,500, 4 minutes, 56 seconds, 82 knots. Crossing 5,000, 8 minutes, 0 seconds, 80 knots.
Copy that. 8 degrees.
All right, crossing 7, 13 minutes and 8 seconds, 80 knots. All right, getting ready to cross 85. 17 minutes, 51 seconds, 81, or we'll call it 80 knots.
80 knots, 7 degrees Celsius, 470. I'll write down things as fast as I can here. 9.0. Okay, you can level us off at 8,500, please.
Okay.
What we'll do is once you've gotten their setting and you think we're speed stable and the engine's stabilized, then we'll start a timer. We're going to wait at least 3 minutes before we record data.
Okay.
Allows airplane to establish its equilibrium.
So we've been maintaining 82 knots this whole time.
Okay.
Level at 85, we're past 3 minutes.
All right, so I'm going to record 82.
All right.
The time was 3 minutes. Our fuel flow leaned your way is giving us 5.8 to 6.2. Outside air temperature here is 6. I've got it all recorded.
Okay.
Oil temps sitting there at 181. That's really good. Go ahead and enrich it.
Okay.
And your new target RPM is 2450. Start leaning.
Okay.
Very slowly. Okay, we're going to watch all of these exhaust. This is now watching to see all the exhaust gas temperatures. Something's going to lean first. And it's looking to see which one's going to lean first. Now, you can feel the power coming off. We are on the lean side right now.
Okay.
Just stop there for a second. Let it keep dialing down. Now, we've lost 130 RPM. You'll need to adjust your pitch. Well, you're doing a good job. You're holding your pitch. We want to hold altitude, so we're going to lose a lot of speed. Now, this gauge is confused because it's like, well, is that really your peak? No, not really. But this is where you feel more comfortable.
Right.
Would you feel like this is a good cruise?
Yeah, I mean,
Power
just feeling the engine, it feels like it's a little bit on the lean side,
Okay. But
it does feel okay.
you're not like, oh my gosh, something's trying to escape the cowling.
No, not at all.
No parts are departing. So a hallmark of a really good leaning, especially in a peak, is how close the EGs are relative to each other.
Okay.
And as your clever device is saying, you're a 58 degrees difference between the hottest and the coldest. That's more normal for a carbureted stock exhaust.
Gotcha.
When we get the power flow on there, I hope we're going to see a difference. Well, we should.
We are.
It's been about 3.5 minutes. Our airspeed, as you predicted, came back up.
About 93,
93?
what I would call it.
93 to 94. We'll give it a little benefit. Your fuel flow is doing pretty well. Right after I said that, right?
Right after you said it.
Right. 6.0 to 6.3, I think, would be an accurate number for that. Outside air temperature is 7. Now, PHTs. PHT 337, 1417. Number 2 is 323, 1434. 349, 1461. 38, 1398. Okay, so you may enrich in the airplane and then take us down gradually. We're probably going to play with some clouds at 5,500. I hope not. But see if you can get us to 5,500 and we'll do the next round of testing.
5,500 set.
With the power flow system, the maximum available RPM is going to increase, usually by about 100 to 150 RPM. Therefore, if you're shooting for a particular power setting, say 2450, it's going to take a smaller percentage of the available throttle to hit that RPM level. 2450 is a smaller percentage of 2700 than it is of 2500, which was probably your maximum RPM pre-power flow. So the engine's turning over less fast. It's not burning. It doesn't burn as much fuel in cruise flight because you can get the same power out of a smaller percentage of the throttle.
We flew the rest of the altitudes and power settings and gathered all of our data on Darren's performance profile, then we made our way back into Daytona Beach International, where we then began removing the old stock exhaust to make way for the installation of the PowerFlow tuned exhaust system.
Daytona Tower Sky 942 Foxtrot Alpha 2.
I'll go ahead and load ground in there so it's less work for us.
942 Foxtrot Alpha. Order 408, number 1, runway 25 left, clear for the option.
408, number
Traffic,
1, runway
10
25
o'clock,
left,
1
clear for
mile,
option.
100 feet above.
2 Fox Alpha, turn left heading 210.
Clear to land for runway 25, right, that is 167.
Coming down through 70.
2 Fox Alpha, contact departure.
942 Foxtrot Alpha over departure, see you on the way back.
We're gonna float a little bit. Get that side slip going. Now we're just gonna get down here in ground effect, let the airplane tell us when it's ready to stall.
Sky 702, Golf Romeo Daytona Tower, change my frequency 120.7, hold short, runway 25 left. Two Golf Romeo, hold short, 25 left.
Alright, we can make whiskey.
Well done.
stock exhaust. You see the problem with these right here? It leaks. All of them. A lot of times on the stock exhaust you'll get cracks in this can right here, especially if the airplane's used for training.
This is what's underneath that shroud. This is our collector assembly. The idea behind tuned exhaust system is a couple things. Number one, balanced length. So each cylinder should have a balanced length. But it also should have the right diameter. So it's both diameter and length that matter. Turns out that's 3.5 feet per cylinder. It's a lot of tubing. But this is why you see this big long loopy section, is so that we can totally get us to the right length. But now this section is a big radiator. These are sealed tubes. The only welding is to attach the end plate here. These 4 tubes protrude through this end plate. They're welded to the end plate. You can see there's like a star in the middle. So that star is welded, and then we weld the rest of it. Then we do something most other exhausts don't do. We send this out for heat treatment. In particular, it's called an anneal. It's a bright vacuum anneal. So this entire thing is sent out, and under intense vacuum is heated up to, I think, 1825 degrees, and then for 20 minutes it's held there, and then it's rapidly quenched. So this material is as soft as it could be. Every time you run your engine, you're functionally stress relieving it. But annealing takes all the stresses and all the stress from this thing being built, this being formed, the welding going on, and it brings everything back into solution. So there's not a particular hard point or stress point there. It's all kind of homogeneous now. Okay, so what we've got here is a Cessna 172 PowerFlow tuned exhaust system with our short stack option. So this would be right here. So these headers are they're relatively short. They're going in here, and they're going through the long section. This other side, these really long pipes, we're trying to get the right length, because what they're going into is this. They're going in a shorter length of this tubing. So we've gone to great lengths to get it there. That's why those tubes are so long. We're trying to get the balanced length, we're trying to get the right length, because that's what the tune system has to do in order to function correctly. And there's where you can see this section here is the carburetor heat, this section here is the cabin heat. This is the same part, just has a shroud on it.
The design of the tuned exhaust allows the engine to develop a greater percentage of its rated horsepower. We're not doing anything that the engine isn't designed to do. We're just letting it work the way it was designed to work, and without restricting the flow, which the normal standard exhaust on most GA aircraft does. It's a choke point on the engines. And most people can sort of feel that, because you can feel when you give it the throttle, it stumbles a little bit, usually before it starts to open up and develop full power.
So this is the tailpipe. This is a 2-inch exit, continues 2 inches, and in fact stays 2 inches throughout. But inside of it, where these screws are, that assembly going up to here is a sound chamber. It's an attenuator is the technical term. In fact, it's called a non-obstructive attenuator, because the gases don't have to go through any pathway. They just continue straight out. I'm going to show you what it looks like inside. What's in there is one of these. See how you can see straight through it? So the gases come right through and come out there. The pathway is unchanged for them, but they're running down a sound chamber. So here's my cheesy demonstration, but it'll work. I'm going to remove my mask so you can hear it. This is my voice. 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 It's a pretty effective attenuator, but it doesn't get in the way. A traditional exhaust system, the gases have to diffuse through tubes and holes, and they wear out. This will eventually wear out, but what wears out is this. This fibrous outer layer has a 400 to 800 hour life expectancy. We specifically designed the exhaust system to be easy to maintain. So when that happens, it's held in by 4 nuts and screws. You get the new one, and you put it in, you line it up, you drill the new holes, and it comes with new hardware. You're done in a half an hour, start to finish. No sending the muffler out for rebuild or anything like that.
All right, so we're getting ready to go do the test flight now. We're gonna suit up with our life vests. The wind is it's ripping out of the west right now, and we've got some cloud cover here over the airport in Daytona, and then we've got a little bit of cloud cover to deal with out over the ocean. So we're gonna take a little bit different approach to how we're gonna do this climb and descent profile, because we need a constant airspeed, uninterrupted climb pretty much in a straight line. So we're gonna find a long strip of ocean that has clear skies, or as clear as we can get it above it, and we will go from there. Start the climb at about 700 feet again, start the timer at 1,000, and hold that airspeed all the way up. Really excited to feel the difference of the airplane and hear the difference in the engine. I'm really excited to see what the EGTs and CHTs are gonna do in the fuel flow. Fuel flow is what's gonna make me really excited if we're able to really dial that back while putting the same amount of power out as we could before. So everything's installed. We're done with the pre-flight, topped off with gas. We're gonna suit up with our survival equipment, life vests and everything, since we'll be out over the water. Let's go do this post-installation test flight. I'm super excited to see how it feels.
All right, the mixture's rich. We're gonna get all set up for a climb here. I think everything else looks good.
You remember the sequence and callouts?
I believe so.
Yep, good. Clear on the right, as far as I can see.
Okay, and we're gonna level off right here. Looks much better that way.
Yeah, let's go south. That's a good idea.
Let's go south. All right, we're stabilized on about 81, 82.
Okay. As you pass through that 1,000, start the timer, please.
All right, climb power is set. Time, 1,000 feet, 81 knots.
Roger that. And we're off.
Crossing 3,000, 3 minutes and 30 seconds, 82 knots.
The rate of cylinder head climb has now dramatically slowed. It's only gone up 1 degree in the last 500 feet, which is about where we normally see. So this condition kind of represents sort of like a worst case. I'm in the Rockies or I'm in a mountainous area. I got to keep doing this sustained climb.
Right.
So you're really demanding a lot out of the engine. We're running ahead of the stock exhaust, despite it being 4 to 5 Celsius hotter today and way more humid.
5,000 feet, 7 minutes, 48 seconds, 82 knots.
Copy that. Your Honda cylinder now is just broached the 400 mark. It's 404. But
Gotcha.
It is by no means a particular hot concern.
Right.
We're running almost 30 seconds faster to altitude thus far.
Cool. And that's with worse temps.
With worse temps. So there's more
Outside.
performance had it been ideal, and we could have done it all like that, but that just didn't work out for us, and that's okay. Yeah.
All right, crossing 6,000. That's 10 minutes and 12 seconds, 80 knots.
It's holding that RPM number for quite a while. Still at 2480, which is where it's been for 2,000 feet, which is really impressive.
Wow.
Now your CHTs are starting to back down as your power density and all that stuff's decreasing a little bit. Now the CHT is just starting a little bit of a climb up, but only very barely, because we just touched the mixture. You raised the mixture about 40 degrees.
On the EGT?
On the EGT.
Got it.
So enough to give you, hey, you got to get out of a bad situation. There's a little more there.
Right. 8,500 feet, 17 minutes and 17 seconds, 80 knots.
Copy that. So in the end, about 30 seconds faster to altitude, despite it starting out significantly, reasonably warmer. Normally when the power flow is put on, we anticipate seeing more air into the cylinder, and typically the fuel flow will go up a little bit at wide open throttle settings.
Right.
However, on this climb, we were showing a gain of 20 to 30 RPM at the lower fuel burn with the power flow. Not by a lot, 2 to 3 tenths. And yet it was a 20 to 30 RPM higher number. And it was warmer by 3 Celsius on average. If I had my own video show, the most appropriate segue is stay tuned.
Yep.
Stay tuned. Not the only thing I could say. That'd be perfect for what I'm doing.
That's right. Stay tuned. Particularly on your exhaust.
Exactly. Well, once in a while when someone really starts kind of doing a little fun bantering, I say, I'll say, we've done exhaustive research. I know it's a lot to intake, but, And then they're like, oh, please stop, you're killing me. I'm like, I'm sorry, you're feeling under pressure. Yeah, bad.
That's good.
We're going to go to full throttle now.
Okay.
Because we're going to start from full throttle anyway. Might as well go to full throttle,
right,
and play with it. So let's go ahead and go to full throttle, right, and lean to best power as you've seen it. And then after that, then we're going to play with the mixture to see how far down we can take it with the engine.
All right.
And I'd like you to slowly start leaning the engine. I want to see how many RPM we can take out of the engine smooth. So when you start to affect the change, just kind of stop, wait a moment or two, like right there. So wait a second, let it all equalize. Watch what happens to the EGTs.
They're going to level off and start coming down.
Yeah.
I see that already.
How would you characterize this? Somewhat smooth?
Somewhat smooth.
Is this past your comfortable point?
Yeah, I'd probably want to go a touch more rich.
So let's go a touch more rich and just give it a second, because you could see how much you just affected that.
Yeah.
So I think there's a sweet spot somewhere in the middle. What I want to try and do is I want to get us to 2450, because if I'm doing it right, we should be able to go lean of peak and save you fuel and run the engine cooler and get the same airspeeds.
Got it.
Of course, I'm attempting to show you on camera with this all the different things that you're going to get to play with as you're flying and doing a lot of cross country. So don't be afraid to do this kind of thing, because number one, Lycoming says if you want the engine to run cooler, lower cylinder head temps, lower oil temps. Well, you're going to do all of those.
Right.
It doesn't matter what the EGT. All you're doing is cooling you're cooling with extra air instead of excess air instead of excess fuel.
Right.
That's all you're doing. And right now, this is trying to say, hey, we think you're 7 degrees lean to peak. I'm not sure I buy that, but you are a carbureted engine. So this is really kind of cool. Now we're down to less than a 40 degree difference. So I think we might have actually finally found our sweet spot. So we were, really, it wasn't 2610. We wound up starting at 2530, and we got it down to 24. Well, I was trying to get it to 2450, and it's now 2430. So previously, on the rich side of peak, we were burning a gallon an hour more, 1 to 1.2 gallons an hour. The only other one to get would be wide open throttle. All right, please. Now that's good that you're getting more net RPM. Previously you could see maybe 2690.
That's pretty good. When it's been stable, it's been 2730.
Yeah. 2728 to be exact.
Yep.
Yeah, so I mean that's some solid. Okay, does it make more power? Clearly.
Right.
You can go ahead and turn around if you'd like, and you can back off and descend and all that stuff. So your airplane can really get up and go. That's really good.
Daytona Tower, Skyhawk 80991, straight in 25 left.
80991, Daytona Tower, runway 25 left, to clear to land.
25 left, clear to land, 80991.
But the other thing that's going to happen is your engine should be a lot more responsive. So if you ever needed to goose it for going around or whatever, it'll do it.
Got it.
Stock exhaust, well, you had no baffles, but it generally bogs the engine down for a bit. Doesn't have that happen at all.
Gotcha. 25 left. We're on the approach path.
Contacting ground. Have a good day, sir.
Correct runway.
Runway confirmed.
476, turn right DN and contact ground, no delay exit and traffic zone shore final.
476 right at the end and contact ground, no delay.
November 991, go around.
Going around, 991.
November 991, spark 12041 Able, left traffic 25 left, I'll call the crosswind turn.
Left traffic 1204 on the squawk.
Right.
Notch the flaps up one. That's good. We're not even at VY.
6 o'clock.
Yeah, cool. That's cool.
500 feet
Sentinel aircraft,
below.
increased productivity on and in the vicinity of the airport, wind 200
22 Celsius. Getting down to VY, doing 1,000 feet a minute with 3 people on board.
991, crosswind turn is approved, I'll call the base.
Crosswind turn approved, 991, we'll wait for your call.
And you got your go-around practice for
I
today.
was going to say, you were just telling me about juicing the power on a go-around, and there it went.
Have both traffic in sight, 80 Romeo.
Perfect, so you're number 4, following the Cessna, turning base, runway 25 left, clear for the
Traffic,
option.
10 o'clock.
Number 4,
2
following
miles,
Cessna, turning base, over
300
the option,
feet
25
above.
left, 80 Romeo.
Alright, runway's ours. Ours coming to idle. Runway's made.
Oh, sure, roll it on.
If you're developing CHTs in the 400, 450, 500 range, that's severely impacting your engine's longevity. And with the power flow on a properly tuned engine, you're usually seeing 380 max, even in climb. So that's significant. You keep it in the healthy operating ranges almost all the time. You can develop your full rated horsepower at that RPM and at those engine settings without stressing the engine. And you're never in a situation really where you're trying to get more out of the engine that it's capable of producing. You're going to get the rated horsepower or very close to it in all operating regimes of the aircraft.
Darren spent many hours behind the desk compiling a summary of our before and after numbers on these flights. All of this data has been corrected for temperature and pressure, and here's what we saw. Time to climb from 1,000 feet to 8,500 feet above sea level was 34 seconds quicker with the power flow. Wide open throttle at 8,500 feet yielded 6 more knots of true airspeed with the power flow exhaust, but at the same fuel flow as the stock exhaust. That right there tells me the engine is running much more efficiently. Wide open throttle at 5,500 feet with the power flow installed yielded 30 more RPM than the stock exhaust, 5 extra knots, and we were burning 1.5 gallons per hour less. That's a perfect example of the engine breathing better. The added leaning capability with the power flow exhaust is also super impressive. The stock exhaust leaned rich of peak at 8,500 feet at 2450 RPM, yielded 97 knots at 7.1 gallons per hour, while the power flow tuned exhaust allowed us to run lean of peak, also giving us 97 knots, but now at 6.0 gallons per hour. Same speed for 1.1 gallons per hour less. The oil was also reading 9 degrees cooler, and all of the cylinders were reading cooler as well. What made all of this finally click for me was when Darren described the EGT and CHT relationship to me in simple terms. PowerFlow yields hotter EGTs when leaning because it's effectively sucking more heat out of the cylinders than the stock exhaust could. The heat has been transferred from the cylinder heads into the exhaust gas. Hence, lower CHTs, higher EGTs. This, combined with better intake through the Challenger air filter, means 80991's engine is breathing better than it ever has. Better breathing means better cooling, better performance, and a longer lasting engine. I'd been contemplating getting the PowerFlow installed for years, and my first-hand experience with the system and the company has showed me that I should have done it long ago. They have a truly amazing line of products that's backed by data, and the company and everybody in it are absolutely awesome. Huge shout out to PowerFlow Systems for making the process so effortless and using their expertise to bring such a needed product to the legacy general aviation fleet. You can learn more about PowerFlow by visiting the link down in the description, and the full-length versions of these performance flights are available at aviation101.com/cockpitclub if you're interested in seeing those. In the next video, Chelsea and I desperately try try to get a word in with Daytona Clearance. We fly over NASA, visit the factory of an experimental aircraft manufacturer, and then we take a few days to cut across Florida, where Chelsea gets some more first-hand IFR experience as we make our way to Pensacola. Subscribe and turn on notifications so you don't miss that upcoming content. Definitely leave a comment down below. I'd love to hear your feedback on this video and all of the technical content we had in it. And until next time, everyone, you know the drill. Stay happy, healthy, current, and most importantly, stay proficient. We'll see you in the next one. Fly safe.